All right, so in this series of videos, we're talking about zeros of polynomials. We've got some specific objectives this semester, this video, this section. We're going to use the factor theorem to solve a polynomial equation, use the rational zero theorem to find rational zeros, find other complex zeros of a polynomial, use the linear factorization theorem to find polynomials with given zeros, learn about Descartes' rule of signs, things like that. So, start with the factor theorem, which is pretty straightforward. We've got a polynomial p of x, and if we know that when we plug in k, that we get out 0, so if p of k is equal to 0, then we know k is a 0 or a root of the polynomial function. All right, so what we're saying here is that with what we learned previously, that we know that p of x is therefore x minus k times q of x plus r of x, but if we get out p of k equal to 0, then that remainder goes to 0, right? If k is a 0 of the polynomial. Okay? So we know x minus k is a factor. All right, so we can use that to check zeros, or to check to see if numbers are zeros of the polynomial, right? So here we've got h of x. We've got it's a third order. We don't have it's in standard form. We don't have any missing terms. That's the key thing to look at. So no missing terms. All right, so we want to know if either of these are zeros of the polynomial. So we're going to put, let's start with 2, and we're going to put our coefficients here. We've got 1 minus a ninth, and positive, not that we need to write the positive, ninth. All right, so we're going to bring down the 1, multiply, add, multiply, that's 2. So 2 minus a ninth, so that would be 17 ninths, because 2 ninths, or 2 would be 18 ninths minus 1 ninth. All right, so that's 34 ninths plus 1 ninth, 35 ninths. So obviously not a factor. The other one we're going to try is a third. So we're going to do a 1/3 here. 1 minus a ninth plus a ninth. Same story, right? 1/3 minus 1, so negative 2/3, negative 2 ninths, negative 3 ninths, right? Which would be negative, our 3's are going to cancel, so negative 1 ninth, and of course that's 0. So this one, 1/3, is a factor. And so what's nice there is that now we know that our polynomial is equal to x minus a third, and then we've got x squared minus 2/3 x minus, that's 1/3, right? 3 ninths is 1/3. And now that we've got it down to quadratic, we can use the quadratic formula and we can find those other two roots. Okay, so we're going to do it again. This time we're going to do some imaginary numbers, right? We talked about imaginary numbers back in chapter 2. So same story here, so no missing terms. No missing terms. And we're going to start with the complex numbers here because we need the practice. All right, so we've got 1, 2, 1, and 2. We're going to bring down the 1. 1 times I, of course, is I. 2 plus I is 2 plus I, right? We're going to multiply that by I, right? So we've got 2I plus I squared, which means minus 1. Right? 2I minus 1 plus 1 is going to be 2I. And 2I times I is going to be 2I squared, which is going to be minus 2, which is 0. So we know I is a factor. Now we're going to do the minus I for good measure. We know somewhere along the way, I think I would have told you, but if not, here you go. I may tell you later too. complex numbers that are roots of a polynomial have to come in complex conjugate pairs. So we know that negative I is going to be a root, but we're going to see it. Just double check, right? So we've got negative I, 2 minus I. All right, so we've got minus 2I minus I squared, so it'll be plus 1, right? Or do I have a minus? No, it's plus I squared, so it'll be minus 1. There we go. We got to double check those things. So the ones will cancel. We've got minus 2I, and that's going to give us 2I squared, which is minus 2. And we're looking at 0. So that means negative I is a factor. And we've got one more to check, which is negative 2. So we've got, let's see, negative 2. Oops. 1, 2, 1, 2, and 1, negative 2, 0, 0, 1, negative 2, 0. Also a factor, right? Now, I'm going to pause this for a minute and show you a better way to have done this. All right, so I duplicated the slide here. So when we did it in the previous slide, when we checked each of these numbers to see if they were factors, we started over for each one. And we really shouldn't do that. There's no need. Once we find that one's a factor, we keep going off the same thing, right? So 1, we got the same thing, 2 plus I, 2I minus 1, so 2I, and then minus 2, right? 0. Okay, great. Then we could say, okay, we want to check and see if minus I is a factor. Well, there's no reason to start from the beginning because we know the first one's a factor, and so the next term, if it's a factor of the original polynomial, it's also got to be a factor of our quotient here. So we've got 1, we've got minus I, the i's will cancel, we got 2, we got minus 2I, oh look, they cancel out 2. And then really, for good measure, what the heck, we'll just do it with a negative 2 also, because why not, right? Pull the 1 down, we've got negative 2 times 1, negative 2. Oh, look, 0, right? And so what does this tell us? That our polynomial, let's change to a different color. Our polynomial p of x can be written as x minus I, x plus I, x minus negative 2, and then all we've got left for our quotient here is 1. So times 1, but we don't need to write that. We're done. All right, and this is a good place to stop.